a robot is driving through app and displaying its commands on LED, and our project is complete. Now it's time to perform optimization or look towards the efficiency of our code. First of all, we need to clean this code, as all of the code is jumbled up into one single file, which is not a good practice, and it's quite hard for anyone else looking at the code. We need to create libraries and header files to make our development more representable and understandable. So in library, I will create 3 folders: OLED display, then motor control, and Wi-Fi data processing. These are the 3 libraries that we will be producing to divide the code for building code more professionally. Let's start with OLED. In OLED, I will create same named files, which is oled.h and oled.cpp. Let me do this again for the other 2 files. Now we have created all of these files. These files have to be exactly of the same name of the folders or library directory we are putting, starting from our OLED display.h. In OLED.h, we are going to be first telling this header file what are the included libraries and what are the functions. In our scenario, the included libraries are these, although they will be still in main file, but these are the main libraries, and this is the definition of the object that we will also define here. But this time we are going to tell it as an extern, meaning there is somewhere else that this object has been created of this type, and you have to utilize that. It is going to be defined in a CPP file somewhere in the whole project compilation that you have to find. It is not defined here, but you can access it. Now once that is done, we have to tell the functions we will be creating. It is going to be display arrows, a simple function. Now in header files, we have to make sure that it is defined only once, meaning OLED is included here like this, OLED display.h, as it is now giving me as a suggestion as well. This gets included into the main file, but we have to make sure that it does not get included again and again, and for that we utilize if not defined then define. And once this whole is defined, end the if condition. So it's a sort of an if condition that is going to be applied. We have to tell it that what we are defining, OLED arrows header file. This is the name of the definition we are going to be doing. So define this. Now you see this is the definition, and it is going to apply an if condition to it. If it is defined, meaning it is defined or included, then you are going to not do it again. Save it. This is going to be simple one. Let's move to the OLED display. The first thing we do here is we write the same display.h file here, because we want to access the header file and add functionality to it. If we go here, we see that this void function was created, filling the values inside of this display arrows function. Let's bring in the conditions. If the request is to be write, then write the write code, left code, up code, down code, and stop code. Where does this request comes from? This is the request that we receive from the client. So I am going to be defining it to be of the same data type, which is string request that we will receive when we call the display arrows. We have to now fill in the values. Let me quickly do that. All the values are added. Let me highlight it and format it so we can easily read it. Stop is just drawing a circle which is going to be starting on the middle point of our screen and having an increasing radius to 3 values. The logic is same for all. For loops are utilized to draw multiple lines to make it more representable in the middle. right, left, up, down, forward. Save it. The functionality has been added. What we need to do once we are here, we need to just act upon the request. But remember, whenever you are here, you need to first clear the display using display.clearDisplay. So whatever was shown on the screen is going to first get cleared, and then you define this and you are getting out of it. Before that, just perform the display.displays. Whatever you decide, you display it. When you enter, you clear the display. So this is going to be the display arrow function. Let's now utilize this display arrow function into our main CPP. First, we are getting rid of extra things, which are drawing of the lines. And here we are just keeping the display begin and clear display. Other code has been removed. And with the simplification, when you perform the forward, you are going to perform display arrows with request. Or we can make it simple as well. Whatever the if condition is, you are going to just display the arrows of the request. And we have to tell it here as well that you are going to be receiving a string of requests. Now before running this whole code and uploading it, we need to verify it. As we can see, there is right, request is right. For left, request is left. For up, we meant forward, so we are going to replace it. And for backwards, we meant not down but backwards. Forward and backward are updated. There is a stop. We don't want to look into up and down, increasing and decreasing of PWM. So now our code is ready. Let's upload it. Let's connect our ESP32 and upload the code. We will be opening our web browser and it is sending the forward key. Let's stop it and open up the terminal. It is accessing through IP address. Let's send forward and we can see the forward is now displayed. Let's go into right. Now right is working. Left is working. One motor is making too much sound. Down or backward. Backward is working as well. Let's try stop. A circle is produced and it is now stopped. So our code has been improved aesthetically by good development practices. It is divided. Let me now improve it further by dividing all of other components into header files and make them libraries.